So my research looks at what are called the effluent limitation guidelines. These are a set of rules that the EPA finalized that look at wastewater discharges from steam electric power plants, so most notably coal-fired power plants. So coal-fired power plants are actually the largest industrial source of water pollution in the United States, so people tend to think of air pollution and they're bad for that, but they are also really bad when it comes to water. And I look at how power plants can meet these rules using something they already have on site: waste heat. So I take models that were developed here at Carnegie Mellon of coal-fired power plants and find ways to integrate both the use of waste heat within these models and different models of water treatment, so things that can use that waste heat to effectively treat the wastewater they're producing and comply with the effluent limitation guidelines. We do this because the conventional technologies that they are using and that the EPA thinks that they will use electricity to drive processes, and you don't want coal-fired power plants to use electricity to treat their wastewater because in doing so, they produce more air emissions. We've actually done some research into how much air emissions they produce, and it's enough to counteract the benefits of treating water in the first place. So we're looking at using waste heat-driven technologies and processes so that we don't have additional electricity being generated at coal-fired power plants, which means you don't have those additional air emissions, while simultaneously treating the wastewater that's being produced so you don't have those discharges into the environment and impacting receiving water bodies.